So now we're going to go into talking about some variables, some data types, how to write some functions, and what I would suggest is code along with me, type the things that I type, and see what happens for yourself as we go through. So the first thing I'm going to do is I'm going to show you the Zen of Python. So if we say import this, and if you put it into your own, you should see here the Zen of Python comes up. And these are some things that we should try and follow whilst writing a lot of our code. And we should, as I've said before, we should try and make it simple, easy, understandable, and obviously that is all encapsulated in the Zen here. And so that's kind of interesting, I suppose, but it's one thing making your code nice and understandable, and I suppose it's another thing understanding the code that you're writing. So we really need to start with typing things in. And as we all know, computers will only really do what you tell them, and they often take things quite literally. And so Python will rely completely on things like the placement of commas or the placement of parentheses so that it knows what's going on. And it's not very good at figuring out what it is you mean, therefore you need to be extremely explicit. And by this, I mean that if we type print, if it will let me, print, print, and print, you can see that Python sees them as three completely different things. The first print here comes up in green so that we know it's a function, it's an inbuilt function. The second print here, all in capital letters, but it doesn't come up as anything. Therefore, Python is interpreting it differently to how it interpreted the first print. And the third print here, we have one capital letter and the rest are lowercase. And again, Python is interpreting that differently. So the case of your letters matters. Something else that we need to know is that spaces matter, so white space. So if we want to name something my variable, we would just, my variable is going to be a car, and we run this, we get an error that says invalid syntax. And that's because white space here is being interpreted as something that Python doesn't really know what to do with in this case. However, if we put an underscore there and we get rid of that white space between the two words and we rerun this, my variable suddenly becomes the variable a car. And so case matters and space matters, because if I now try to write my variable with a capital M and we want it to return something, it says name my variable is not defined. However, here we've obviously defined it, but what we really mean is everything in lowercase. And if we then run that, we can see that a car is returned. So then one of the next, I suppose, most distinctive features of Python is its use of indentation to mark different blocks of code. So this is a really important concept because without it, your code will not compile and this will result in your programs not running. So in simple terms, indentation just refers to adding some white space before a statement. And I know I've just said that white space is bad, but white space used properly is good. And what we do is we can say, let's say programming language here, and we just set the empty string. And we might want to say that if our programming language is Python, we want to print good choice. However, if our programming language is something else, we might want to print bad choice. Okay. Oh, I've spelled choice incorrectly. And here, we haven't set our programming language to anything, our variable to anything. So if we set it to Python, we say good choice. But what you can see is we've had to indent these print statements after our if-else statements. So this is, I do this indent by pressing Shift once, and that will indent it to the correct degree. But here, the white space is super important in making code run. So in Python, you will come to see that there are places where it is good to use and you need to use white space, and places where it's not good to use white space. Now, this little bit of code that I've written here doesn't really conform to what I was talking about in the talk about making our code understandable and readable. What we really need to do is put some comments in. So the first thing we can do is we could put a hash, and we could put a comment here, code to say if your coding language is good or bad. So we have a comment that describes something about the code that comes after it, and because we have the hashtag, that's telling Python that we shouldn't interpret any of this as executable code. It's just something there for a human to read. So if we execute it, we can see that absolutely nothing changes. Another thing we could do is we can put some, we can put a set of speech marks. And again, this says that everything that is encapsulated by these speech marks is not to be executed as code. So everything here won't affect our program. And if we execute this again, you can see that, again, absolutely nothing changes, apart from we now have some human readable and interesting comments to tell us what's going on. So that's a little bit about typing in Python and how to describe what you're doing in a user-friendly way. Now we should probably start to talk about variables. And we've already assigned a variable up here. We've called my variable, and we've called it a car. But what does that really mean? Because we've already said that you have to be very explicit when you're using Python. So it's quite obvious that this variable here, a car, is going to be quite different to, if we call this my variable 2, which is a number. So as I said in the talk, Python is strongly dynamically typed language, and this means that variable assignment is different to that of other languages. There is no need to declare that a variable is a variable. In Python, it will do this automatically, and it doesn't know what the variable type is until the code is run. Therefore, the variable is created once a value is assigned to it. So a good way to think about this is thinking about a variable as a container for a value. So my variable here is a container for this, and my variable 2 here is a container for this value. And if we want to be a little bit more specific, we can say that it's a label given to a certain location in your computer's memory. So you can assign it a name, so in this instance, we can assign it a name, and this name will point to a place in memory to find whatever it is that it contains. A few notes on, or a few rules that we should all follow when creating variables. You should always start your variable name with a letter, or if you want to be a little bit on the fence, you could start it with an underscore, but you should never have a numerical variable name. So you cannot have a variable that is named 5. So 5 never should equal red, because that wouldn't really make much sense. But we could have red equals 5. And I think it's probably fairly obvious why it works that way around. You don't really want to start changing the numbers, but you can create some good variable names to contain some numerical information. Now, as I've already shown, variable names are case sensitive. So I'll just show again, red spelt with no capital letters, red spelt with one capital letter. They are both different. They do not point to the same space in memory because Python interprets them as different variables. And one more thing that we should always remember is we shouldn't recycle variable names. So later on, if I need to reuse the variable name red, I really shouldn't call my next thing red again, because now we're in an instance that everything ran after this bit of code will think that red is the equivalent of 10 or is equal to 10, and everything before thinks red is equal to 5. And if you notice, Python hasn't flashed up an error message to tell me that I've recycled a variable name. It thinks I've simply reassigned the variable name to something else. And I'm sure you can see how if you reuse the same variable name in certain places, you will start to get or you'll start to run into lots of different issues. Okay, so that's a little bit about how you should name variables. Let's talk a little bit more explicitly about variables. So if we make our variable called number and we set it to 27, we can see that number equals 27. Now with Python, there is a difference between a number without decimal places and a number with decimal places. So this number is 27, but if we say number 2, equals 27.5, and then if we look at their type, so if we go type number, we will see that the type for our first number is an integer, but our type for our second number is a float. And this is, again, something very important to remember. Python sees integers and floats, even though they are both numbers, it sees them as something quite different. If we then look back at our my variable up here, if I just copy and paste this to bring it back down to where we're working, and we ask for the type of it, we can see that comes up str, and that stands for string. And that's because we have written in a word and we've put quotes around it, and therefore that obviously won't be used in a numerical calculation, but it can still be used as itself as a string. We can also, and I suppose I've alluded to this a little bit, we can also assign the same number to multiple variables. So a equals b, equals c equals 100. And if we ask it to print out a, b, and c, they are all equal to 100. So that's something to be wary of. And it can be helpful, or maybe it could be a hindrance. It depends how we use it. Another thing that we should probably be a little bit wary of is that we can swap and interchange the values of these variables. So if I say first, second equals the string Python and the string Java, two very popular coding languages, and then I say second first equals first second equals second first, and then we print first second, we can see that we've turned them round. So initially, first was Python, because that's our favorite programming language, and second was Java, because that's our second favorite. We've swapped them round, and first is now Java, and second is now Python. So something just to be a little bit wary about. And then if we want to delete something, there is this delete function, so we can delete second, and now second doesn't exist. It's saying the name second is not defined because we've deleted it. There is a slight difference as well between assignment and algebra. So if we say that, I think I've used A, haven't I? So A1 equals 4, B1 equals 10. If we then say A equals A plus B, excuse me, if we say A1 equals A1 plus B1, and we print A1, we get the answer of 14. And so in algebra, this doesn't really make sense. It's not a valid algebraic expression, as A appears twice here, but it's a very, very common expression in a computer program, because we're saying that we essentially want to update, we want to evaluate what's going on the right-hand side, and the result is assigned back to the left-hand side. So we've updated our variable A1 so that it equals 14. So that's just something, again, to be a little bit wary about when you're using Python and looking into variables. So let's start thinking a little bit more then about the data types. And so this is refers to the classification or the categorization of data items within a Python script. And obviously we've touched upon that up here a little bit. And so the type is the type of object that a variable is associated with. So the type, as we've seen, could be an integer or a float or a string. Excuse me. And the type affects how the computer stores this object in memory and how operations, such as things like multiplication or division, are then performed upon it. So all variables will innately have a type, and we can use, and as I've shown before, we can use the type function, if I just scroll up a little bit here, to tell us what that is. And that's really powerful, because if you're trying to do, if you have a big complicated program and it breaks and it's not outputting anything, you might be able to go back and find out that you're adding an integer to a string. And obviously that is something that can't work and is not allowed. So just to go a little bit back over, we have integers. So we've shown up there that we have our numbers. I can't remember what I called them. I think I called them number 2. So let's get back to number 3. So number 3 equals 43. Number 4, this can equal something very long. Let's have number 5 equaling something like this. Number 6 equaling something like this. And number 7 equaling something a little bit more zany, like 5 plus 4j. And if we now look at the type of each of these, so if we look at the type of number 3, okay, that's obviously an integer. Okay, we know that already. The type of number 4, we're going over old ground here. Again, still an integer, even though it's a very long number. We look at the type of number 5 and number 6, we'll see that they are both floats, even though this 2.75 and 42.0, you might imagine that the 42.0 might just revert to an integer, but it doesn't. It stays as a float. And then if we look at the type of number 7, we'll see that actually complex numbers are a type. Okay, that's great. We know that we have to be very explicit, and we know that there are various different types, even all just for numbers, but we can use this to our advantage when coding and programming, because we might want to change between types. So this is called type conversion or type casting. In some cases, it does happen implicitly, but in other cases, we can instruct our program to change the type. So if we want to add number 3 and number 4, and we want to say our answer number 1 equals that, okay, that's great. If we print out answer 1, we see that it comes to this ridiculous number. And if we find out the type of answer 1, we can see that it's still an integer. So we've added 2 integers together and we have an integer. But now what might happen if we add number 3 to number 5? And if we say this, we call this answer 2. So what we're doing here is we're adding an integer, to a float. And answer 2, it comes out as a float, as we can see here. And we can check that by going type answer 2. That's great. An integer plus a float then becomes a float. So if we then go on to divide 2 integers, so let's divide, well, let's define some more because we've got some silly numbers. So number 9 equals 9, number 10 equals 10. If we want to say number 9 divided by number 10, answer 3, call it so that it prints it to the screen, we'll see that we get a float. So if we go type answer 3, okay, great. So we've divided 2 integers and we have automatically got a float here. So that's great. That's something that you would expect to happen. However, what we could do is we could do we could do integer division, and we could do the 2 slashes, and you'll see that we forced it to go back to an integer. So the result here, we forced it to be an integer. If we print to screen, we can see that actually it's just defaulted to 0, because 9 divided by 10, if we force it to be an integer, it would go down and become 0. So in general, operations that mix an integer and a float will generate a float, and operations that mix an integer or a float with an integer or a float with a complex number, they will return a complex type. And so you'll see that when you are mixing and matching, you will normally return the answer that is more relevant to you, so the float or the complex type. But if you're ever in doubt, you should always call the type function, the type method, and you will see what's actually going on. So then, if we want to force something to be a float, we can do that. We can do some type conversion. So let's say number 12 equals simply 1.5, and then we say that our cast equals int number 12, and then we go type cast. We've forced number 12 to become an integer, and it's actually become, instead of 1.5, it's become 1. So we've done some typecasting, and by calling the integer method, we've forced a change in the data type. And we can do this for floats as well. So if we wanted to put in Instead, we just said number 12 is equal to 1, and we put a float. We can see that when we call that, it then is printed out as 1.0, and our type has gone to float. So this is obviously very, very useful in quite a lot of circumstances. So obviously rounding is going to be applied when going from a float to an integer, and obviously the values after the decimal point are discarded, and so sort of a common task here would be converting numerical types to and from strings. So we might read a number from a file as a string, or a user might input a value into Python, which reads in as a string, and we might want to convert it to either a float, or we might want to convert the string that's been inputted into a float or an integer. So if we now define our string 1 as a string here, so 15.07, and we just check the type of string 1, which is obviously going to be a string, and so Python does not see this at the moment as a number. It does not see it as anything numerical. We couldn't, for instance, say string 1 plus 5. We will throw an error message because you can't add a number to what it perceives as letters, so it's a string. So what we might want to say is float string 1 plus 5, and there we get an answer. Because by forcing it and converting it from a string to a float, we're then able to do numerical operations on it. That's great. It's really, really useful. But this now leads to something that I wouldn't call an obvious problem, but is quite a big problem when we are using floating point numbers. So a little bit of background to this: when we're using the familiar sort of base 10 numbering system, which is obviously familiar to all of us, we can't represent numbers such as 1/3 or 1 divided by 3 exactly as a decimal. If we liked using something like base 3, then we could, but base 3 is pretty difficult for our brains to comprehend and to use day to day. So a consequence is in Python that fractions that are simple in base 10 can't necessarily be represented exactly by our computers in Python because they're using binary, which is obviously a different base altogether. So sort of a classic example here would be if we said 1 divided by 10, and here we get 0.1. And this can't really be expressed in binary. Now, I'll show you why this is so profound, and it has such a profound effect on the way that arithmetic's done on the computer. So let's say can't remember what numbers we got to, but number 15 equals 0.1 here. And if we just print that to screen, just for our own sanity, we see that it does indeed equal 0.1. But if we ask Python to print this out to, let's say, this is why it looks silly because I don't choose enough significant figures, but let's say 30 to 30 characters, we'll see that there's a little bit of funny business going on here. And don't worry too much about the code that I'm writing here. It's the output that is really important. What have I done wrong here? Oh, that's why. Got my bracket in the wrong place. So what I've asked it to do here is print our number 15 out to quite a high degree of accuracy. And instead of 0.1 or 1 divided by 10 being 0.1, our computer actually sees it as 0.1, a bunch of zeros, and then some numbers. And I'm sure you can see how this could, I think this is what, 17 significant figures, something like that. We'll see, I'm sure you can see how this could be a problem if we need something that is very, very accurate. And indeed, there have been cases where planes have fallen out the sky because of exactly this type of error. When it's compounded over many years, things can start to go a little bit pear-shaped in the calculations and in the code. And so it's something that you really do need to be aware of. And it's all to do with the way that Python interprets the numbers that you're putting in binary. Another thing that we could sort of show here to show you how this is a little bit annoying is that if I show you an example of sort of inexact representation, so if we have something that says x equals 11x minus 10x, oh, excuse me, and I'm doing this in Markdown here, so this won't execute as code, excuse me, so this is now Markdown, this won't execute as code, I'm just writing this here to show you. If we set x equal to 0.1, we could then write that x is equal to 11x minus 1. And that's fine, whatever, who really cares? But if we now, using our knowledge of how Python can interpret things, or how the computer can interpret maths a little bit wrong, we write a little function to calculate this over not even that many iterations. Say x equals, what did I say? X times 11 minus 1. And then if we print x, so over just 20 iterations, we can see how our solution blows up. At the bottom here, it's gone to over 5,000. So this is why this is such a profound effect of the way Python and your computer works, and why being aware of data types and what data type is being used is really, really, really important. Okay, great. Let's move on to something that's a little bit less numerical now. I haven't actually looked at any of the questions so far. If I have a look in the chat. So it seems that Nikki's on top of most of the questions. After I've, when it comes to the break, I'll have a little look through and see if I can add anything to the mix. But Nikki's, it looks like Nikki's got everything under control quite well. So now let's look into strings a little bit more. Let's move away from numbers. So we've already seen that we can use single quotation marks as strings to, around our letters to make a string, but we can also use doubles like this, and we can say we can also use triples like this, and they all execute exactly the same, and they are all strings according to Python. So that's really good. We can go a little bit further with strings, and we can start to index what's inside of them. So if we want to print, let's use summer as an example. We want the first character from summer. We return H, and Python indexing starts at 0. So the 0th index is the first character, and then it goes up from there. But we can see that if we have a string, we can do these operations on it where we bring back various different parts of the string. Again, in this simple example, not completely useful, but in more complex implementations, this can be incredibly useful. If we say -1, it brings back the final letter in the string. So -1, -2 works backwards, and then 0, 1, 2 works forwards. Now, if we increase our winter string to say cold usually, but some nice days, so just increase the length of it, we can use slicing, indexing and slicing to bring back a bigger chunk of it. So we don't just have to return one letter from the string. We could return everything from the third one to the 11th one. And here we've got LD usual, because I suppose it's caught the last two letters of cold and the first few letters of usually. So great. Can be useful, not that useful in this very simple setting. Now I think we should probably talk a little bit about what we can do with all these different data types, and how we might use them and bring them together. So one of the great things that Python can do, and most programming languages, to be honest, is we can create lists. And a list is simply a collection of different values that are separated with a comma. So, excuse me, as we've said before, in Python, there's absolutely no need to declare the type of a list. And that is a really important thing to remember, because it means we can put different data types into our list. So if we call our first list, we can have the empty list. And so there doesn't have to be anything in there. If we look at its type, we'll see that its type is a list, even though it doesn't contain anything. By calling these square brackets, we've defined an empty list. And we could, if we wanted to, add things into there. So then if we say our second list equals, and we have to have these square brackets, January and February. I've spelled that incorrectly, like that. We can see that we've now got two separate strings in our list. So we've managed to bring together two separate things. This is our second list. So if we just print out our second list, there we go, we've got two things. But we could also make a third list. Instead of putting strings in there, we can put variables in there. And so we have these two variable names already, summer and spring. And if we put summer and winter. Oh, sorry, I forgot an equals sign. And if we print out our third list, we can see that we've now got hot and cold usually, but some nice days. Because summer is a variable name that points in memory to what it contains, which is this string called hot, and winter is exactly the same for cold usually, but some nice days. Okay, that's not too exciting. They're just, they've got single variable types in. So what we can do is we can define a fourth list that has the numbers 4, 6, it has the variable name summer, and it has the string winter. A bit confusing there, but. And we can see that an error isn't thrown. So our fourth list, if we print it, it's got the two integers that we put in explicitly. It's got the variable name summer, which is obviously returns hot, and it's got the string winter in there. So we have various different data types in this list. And if we just look at the type of our fourth list, brilliant. It's still a list. So its data type is still a list, no matter what is in there. And then we can do this slicing on these lists again. So if we put in fourth list, and we now want to slice it, so or index it or slice it. So if we index it first, we want the first thing that's in the fourth list. we can see that it returns the number 4. Excellent. And if we look at the type of fourth list with the 0th index, aha, it's now an integer, because we've called something, we've pulled out something from our list, and it's now saying that our data type is the thing that we've pulled out. So then if we want our fourth list, and we want everything from the 1st to the 3rd, so this will now bring back the number 6, the variable name summer, and the string winter, we will be able to say, oh, no, sorry, I'm wrong. It will bring back 6 and the variable name summer. And that's because the way Python works is it takes everything from the first index. So in our case, because Python starts at 0, the first index is actually the second entry. And it takes everything from the first up until the second number. So actually all this will do is bring back the first and the second. If we wanted to bring back winter, we would have to put the number 4, and there we go. It's brought everything back apart from the very first entry into that list. And now if we look at the type of our fourth list that has been sliced from 1 to 4, we can see that it goes back to just being a list, because it still contains multiple different things. Now, lists are what's called mutable, which means that we can change the elements that are in them. So something that is mutable is changeable, something that is immutable is not changeable. So if we have a shopping list to go to the shops with, and we want apples, pears, and bananas. Can't spell today. There we go. And we want it to be our shopping list. And we press enter. Fantastic. We've got our shopping list. But if we then want to change our shopping list, we can then say, actually, our 0th index of our shopping list, we want to become Ferrari. And if we now run this, okay, that's great. Let's print our new shopping list to screen. And we can see that we are now, instead of getting apples, pears, and bananas at the shop, we're getting a Ferrari, pears, and bananas instead. So we can update the values in our list. We can change what's in there. We can also remove things. So if we say shopping list.remove pears, and we run that, and then we look at shopping list again, we can see that it now only contains 2 things. And so this is great because we obviously are going to want to be able to update our lists. We want to change them in some sense. And I'll also introduce you to another function here called len, which tells us the length of the list that we are looking at. In this case, it's very easy. It's only 2 long. But if we had a data set that had 1,000,010 things in it, we wouldn't be able to count it. We would want the length. We'd want to be able to just type in and find out how many entries are in that list. Not everything is mutable though, and lists aren't the only way of storing information. We can use something called a tuple. And so tuples are like lists, but they are declared with parentheses instead of square brackets. Just like a list, they are, in a sense, a collection of ordered objects, and all the entries are separated by commas. But unlike lists, they are immutable. So this means that once they're declared, you actually can't change them. So if we say our tuple 1 is, and let's go back to our programming language example, Python, Java, and C++. We run that. Okay, great. Now let's look at its type. Tuple 1. And here, our type is no longer a list, it's a tuple, which is super useful. We can slice them again, and I'll just show you slicing before I show you that they're immutable. So if we slice tuple 1 and we say we only want the second index, spelled it incorrectly, we can see that it's C++. But if we then want to change C++ to, I suppose, SQL, and remember I've said that tuples are immutable, here we see that tuple object does not support item assignment. So we can't actually we could with a list, we could change it, but we can't actually change this tuple. It's fixed in how it is. And so, on to the last bit of data types. I suppose a very, very powerful one is what's called a dictionary. And a dictionary is a way of bringing together items or entries in a much, much cleverer fashion. So, for instance, all we've been able to do so far is write in instances of the things that we want to put in our lists or tuples. But in a dictionary, we can put a bit more of a description. So I'm into my cars. So if we say cars statistics dictionary, we declare them using the curly braces, and we can say, okay, we want a make of car, and we want it to be a Ferrari. We want a model of car, and we want that to be an Enzo. Excuse me, it needs to be a string. We want, obviously, the color of our Ferrari to be red. And we might want to include information about the top speed, which I don't actually know, but let's put in something like 200 miles an hour. There we go. And so we can see that, again, this is declared slightly differently because it's a slightly different data type. We're using these curly braces instead of square brackets or parentheses. And actually, the format is very different too. We have here our key. We put these, we put a colon here, and then we put in our entry. So we can say that the make is a Ferrari, the model is an Enzo, the color is red. And that's markedly different to the amount of information that we could put in our lists or tuples. So if we run this, we again, for our own sanity, look at the type here. We can see that it's come up with dict for dictionary. So the class here is a dictionary. And now we can do some, I think, some really cool things, because we might want to find out the maximum speed of the car in our dictionary. So if I put this here, and then we say max speed. So you can see here, it's similar to when we were slicing and indexing, but when we do that with a dictionary, we want to put in our key. And here it will come back and tell me that I have called it wrongly. And here we've returned the value of 200 because that is the maximum speed of our car. So this is a little bit different. A dictionary is mutable, so we can change the things that are inside it. So just very quickly, if I show this, and then we say that actually we want to update the model to be the California. If we then run this, the model is updated to be California. So they are mutable. Dictionaries are mutable, just like lists. And then the final type I want to show you is a set. And a set is simply an unordered collection of data types. So if we put here, we say our set, and this is again called with the parentheses, but this time we will not be putting the colons in because this again isn't a dictionary, it's something slightly different. And so if we put in our set something like that, that becomes our set. Again, for our own sanity, let's say our set, oops, and it's a set. But if we then print our set, we see that it doesn't actually print everything that's in there. It only prints 1, 2, 3, 4 instead of 1, 1, 2, 2, 3, 3, 4, 4. And this is because, as I've said, it's an unordered collection of data types. And the result of it being unordered is that it doesn't support indexing. And I'll show you that in a second. But neither do they support duplicate elements. So then if we say our set 2, we get an error because the set does not support indexing. So there's some of the major data types, and I feel like we're running slightly out of time here. So I'm just very, very quickly going to move on to something completely different. We've spoken about typing into Python and more explicitly some of the data types that we can use. Just going to tie this together with a very quick example of how we can then use all of this to our advantage and actually write some programs. And one of the things I'm going to tell you is something called a user-defined function. And these allow you, or the user-defined function allows the user to perform a specific task by grouping a series of statements into a single bit of code. And you can name this function, so it will have a name, and it can be called by the user. And you will have inputs in there, so you will need to use proper variable names, proper use of spacing, proper use of data types. Excuse me. And by defining function and executing it, you can then use a complex bit of code over and over and over again without having to completely write it out. So very, very quickly, because we're right on the limit of time here, I'm literally just going to write a function that says sum two numbers. And we define it by putting this def in, and then we put a and b as what we might want to define. And we say that c equals a plus b, and we return c. Now, if we execute that, nothing really happens. However, if we then later on want to call our function, we want to add 5 and 10 together, there we go, it adds the two together and we get 15. Now, in this, we should always write a docstring, as we discussed at the beginning, where we have our inputs. A equals first number, B equals second number, and what we return is C equals the sum of the first two numbers. And here we might want to just put a little comment saying calculation happens here. Now, because we've run out of time, I won't go into using functions to update some of our lists or tuples or dictionaries, but I can leave that for you guys to do yourselves. And just remember that when you're writing and you're doing Python, always refer back to the Zen of Python, so that you know what you're doing later on and somebody else does. And always remember to keep track of your data types, because if you don't, you can get into all sorts of problems.